Hello everyone, welcome to another installment of Weekly Roundup for LeetCode. So if this is your first time here, this is a little bit different than the streams I normally do on my channel where we're typically just pushing forward, trying to do as many questions as we can. For example, we're here sitting at 269 questions. Typically what I do is I'd start at the last question we left off at and we just move forward from there. But what I try and do in Weekly Roundups is, throughout this whole journey, obviously there's some questions that either have a terrible like to dislike ratio, maybe they were too tricky for us to solve at the time, or maybe they were just very, particular in whatever approach they required. So I skipped them for whatever reason, right? But with weekly roundups, I like going back to these questions. That way we can round out the amount of questions that we've done and just try to eventually do all 594 of these easy questions. So with these, I like to start on page 1 and just start from the top and scroll down and see if there's any new questions, which I already see there's one here. So for example, this may or may not be new, but at least from the time that I was in this section, which I started in July 16th, so probably haven't been in this section since around that time. Probably this question didn't exist, so it could be a new one. Let's see. Based on the like to dislike ratio, it probably is a new one since it's low, but the good news is it seems like a high quality question. So let's go ahead and start in this one. So it says the smallest even multiple. So we're given a positive integer n. We want to return the smallest positive integer that is a multiple of both 2 and n. So I guess, let's see. Given a positive integer, return the smallest positive integer that is a multiple of both 2 and n. I guess we need to start at least at 2, right? Is 2 and 6. Return the smallest positive integer that is a multiple of both 2 and n. So I'm wondering, let's see. The smallest multiple of both 5. The smallest multiple of both 5 and 2 is 10. Okay, so 10 is the thing that, let's think about this. So 2 and another one. So I'm almost thinking like, we know it's always going to be 2. So we can go from 2 all the way up until 10. I think maybe we can do that. Something like, let's see, for let I equals 2. And I guess we don't want it to be 2, right? So can we just start at 3? I less than or equal to n, I plus plus. Here we go. Eris, sup, bro? This is math theory. Oh, what's up, Eris? Good to see you around again. How's everything going with you? Let me know about your LeetCode progress. Yeah, it seems like there's probably a very easy way to do this with like a single formula, but I'm going to try and take a little more of a brute force approach, but let's see if we can get it just with that. So I think like as soon as I find something, let me see, if n divided by I almost want to do something like if, let me see, we have n, if n modulo I is equal to 0, can we just return, input is n, as output is 10? Oh, but it needs to be the smallest multiple of both 5 and 2 is 10. Oh, I see. But it's not going to be, do we just have to keep going all the way up? What's like our constraints here? N is 150. Smallest multiple of both 6 and 2 is 6. Note that a number is a multiple of itself. Yeah, like how much further will we have to go up? I guess this won't work, right? Because like n, if 5 modulo I, but this is only going to go up to 5. So can we just make it like 150? I'm curious if that might work. 150 if n modulo I is equal to 0 of both 5 and 2. Oh, so it needs to be n modulo I is equal to 0. And I'm all right. I have to go prep for the SAT now, though. Oh, man, I haven't taken... Yeah, it will work with brute force because it's only less than 150. Yeah, I think so too, right? Man, I haven't done the SAT. I took the SAT in 2010, I think. So just, or maybe early 2011. So yeah, I just kind of aged myself there, but that's fine. And modulo 2 equals to 0. Then here, output 10. Can we return I? I'll write the solution in Discord. Damn. Yeah, if you want to write this, writing the solution in Discord is totally fine. Like you can definitely do that. I would encourage you to like write it inside of the channel. So since this is an easy question, we have a channel dedicated for easy questions. So I would encourage you to write it inside of easy, and also make sure to put it behind a spoiler, just in case, we don't want to spoil it for other people watching it. But yeah, I know it's been a long time, right? Given a positive integer n, return the smallest positive integer that is a multiple of both 2 and n. And maybe we don't even want to go, I think here I should just do 0 less than or equal to 150 if n modulo I equals 0 and n modulo 2 equals 0, return I. So n is equal to 5. The smallest multiple of both 5 and 2 is 10. Maybe this should be I modulo n. I modulo n and I modulo 2, then return I. Yeah, I'm definitely making this question way harder than it needs to be. And 2 is 10. Smallest multiple of both 6 and 2 is 6. Note that a number is a multiple of itself. Maybe I just need to let me start writing out some numbers. I think I'll make it a lot more clear. Because we can start going from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. The smallest multiple of both 5 and 2. So 5, we're good on 5, but not 2. So then we get to 10, and that's fine. So if I start from I0, I less than or equal to 150, I plus plus, if I modulo n, right? So 10 modulo 5, that should equal 0, and then 10 modulo 2 also equals to 0. Return I. So why is this one, for that first one, not returning what we expect here? I would expect for us to at least get 10 here, no? Unless 10 modulo 5. Oh, should we not also, maybe I shouldn't even start from, maybe I shouldn't start from 0. There you go, 10 and 10. Let's use all our example test cases. 10 and 6, 10 and 6. So let's go ahead and submit this and see what we get. 77, input is 77, we got output undefined. So our bound should not be we shouldn't go, I guess, yeah, that's the thing. What is the, yeah, there's definitely a mathy thing here that I'm missing. I don't know the highest number to go to. Of both 2, and I also feel like this right here, both 2 and n, that might already give me a hint, right? Multiple of both 2 and n. I guess actually what we can do is 2 and n. Well, I guess anything can be a multiple of itself. What I mean by this, 2 and n. Yeah, actually what we can do is if we start at 5, maybe we can just keep adding 5 to the number, because we can get to 5, 10, 15, etc. We can keep going until we find one. Yeah, actually maybe that will work. Maybe we can keep doing that. It seems sort of weird to have the algorithm be like that. Oh, by the way, you can just not have an upper bound because you still have to find the number, so it doesn't matter. Yeah, I think instead of doing this, maybe we can say do while, let's see. N modulo n is not equal to 0, and n modulo 2 is not equal to 0. And then here, maybe you can do n plus or equals n. And then at the end, do we just return n? Actually, I want to see if this works. I haven't worked with like a do while loop in a long time. Because here, I want to do this while 5 modulo 5 is not equal to 0, but that is 5 modulo 2 is not equal to 0, so then we'll keep doing this. Or actually, this should be an or, right? Then we get to 10. 10 modulo 10 is equal to 0, so that's false. 10 modulo 2 is equal to 0, so that's false, so we return 10. So will this work? All right, see ya, Eris. Thanks for stopping by, man. Appreciate it. 10 and 12. Okay, so for this next one, I think, yeah, we didn't get a chance to do the first one. Well, n modulo n is not equal to 0. Basically, this is the solution, but you can kind of simplify it. Yeah, no, I'm sure. Yeah, anything that's like math related, I think I was talking about this yesterday, like anything math related, I'm just literally terrible at. Check Discord later. Yeah, we'll do, man. Thank you. Like, I wonder if the do, yeah, I think what's happening is like we don't even get a chance, like the do is happening first before we even, so maybe we can just say this. Maybe I just say this. Ten and 6, 10 and 6. Okay, and let's also try out the one that failed for us last time, 77. So we should get 154 here. So you have 10, 6, 154, 154. Let's submit this one. Wow, okay, it may be brute force, but we literally got 100% on both time and space complexity. So that feels pretty awesome. I wish there was a way to like, I think there's a way to have like audience reactions or my own reactions that I can add to the stream. I need to get more into like the Streamlabs ecosystem to figure that out. Nice. Cool, I'm happy with that. That's a nice way to start the stream out. All right, cool. So that was smallest even multiple. And you know what? Let's read the discussion because I'm sure it's like a one line solution. If n is even, return n left shifted. If n is odd, return n also left shifted, but we're introducing a 1 or a 0 depending. The smallest even multiple. But the thing is, I want to learn why this works. The smallest even multiple, n or 2n. Same solution, but small change. Return n times n modulo 2 plus 1. How would that work? If n is 5, 5 modulo 2 is 1 plus 1, that's 2, and n times 2 is 10, okay? The thing is, like, I don't really understand the intuition behind this. Like, why does this work? It's easy to put it there. So if you really found my solution helpful, please upvote it. Okay, it's fine. If n is even, both n and 2 are divisible by n. N is the smallest number. If n is odd, then n is not divisible by n. Just multiply n with 2. Okay, so I was kind of close, right? Yeah, I thought about that too. It wasn't like as elegant, but apparently LeetCode liked it. We still got 100% on both time and space. But yeah, like my thing was thinking, like, as soon as I started writing this, I was like, well, it'll always be divisible by itself. So now we just really need to figure out if it's also divisible by 2. So then we could just multiply it by 2 if that's not the case. That's cool. All right, let's see the next one that we can do. Maybe there's another one on this page that we haven't gotten to. Okay, it looks like we still have everything done on the first page. Let's get to second page. Hopefully we don't run into a really terrible question. So minimum type. Oh, okay. I think we tried doing this one before. Yeah, okay. I do like this one, and I want to try it out again. Okay, so there's a special typewriter with lowercase English letters A through Z arranged in a circle with a pointer. A character can only be typed if the pointer is pointing to that character. The pointer is initially pointing to the character A. And I think in the beginning, so we type the character A, and then we move the pointer the minimum amount. So it's something like the algorithm should be type the letter, which takes one second or whatever unit of time they're using. The second thing is we find min distance to the next letter. Okay, that's the thing. That's the perhaps like the tricky thing maybe. But let's take a word like BZA. Let's open up Excalidraw. And let's see what we can come up with here. So I'm gonna trash this. Amit says, hey man, you're doing a great job. Can you please let me know how to get started with LeetCode? I have started with data structures and algorithms, but I find even the easiest problems difficult to solve. Yeah, thanks a lot for joining, Amit. Really appreciate the kind words. It's always messages like this that definitely want to, keep me going. The one thing I'll recommend, there's plenty of lists out there that you can use, but really the most important thing is just learn the fundamentals. Like I wouldn't even bother with LeetCode unless you feel pretty good with your basic data structures and algorithms. Like learn your arrays, learn your linked lists, learn like basic recursion, learn your trees, heaps, things like this. I would get really good at that, be able to know the time and space complexities of each of the different operations against these data structures, and then you can start applying what you've learned into LeetCode. One of the other nice things you can do too is, let's say you're learning about arrays. Like as you're learning about arrays, you can come into the tags and you can sort by array questions. So as you're learning, you're also doing questions related to that data structure. That could also be like a very good way to approach it. I always put the link in all of the different video descriptions that I do for these streams, but I also do have my own list that I've compiled since I started this whole journey. So on my website, I have raphaelslist.com, and this is a collection of all the top quality questions that we've done since I started this whole thing on July 16th. So almost, 2 months ago or so. One of the nice things here is you can search up the questions, and each one of these questions has like the stream clip, so it'll take you to the video and the exact chapter where we go over it. So this could be like another tool that you can use to also study these questions. So let's say you want to do something with array, you can just search for it here. You type down like array and you'll see all the different array questions here. Sort array by parity or squares over sorted array. You can keep track of your progress. And a newer thing that I also was doing was I was creating playlists based on the explore cards of LeetCode, which I added to this little section right here. So the first one I have here is called the LeetCode Beginner's Guide. You can actually click on this, and this will take you to the playlist I have for this specific explore card. And the explore cards are, on LeetCode on this top nav bar here. You can see there's a ton of different explore cards that try to make it so that you're focused on a single thing. So I realized that while a lot of people might like to view this long form stream, I also realize there's some people that want a more tailored experience. So this could also be another thing for you to practice. So hopefully all that's helpful. And yeah, let me know what you think, and I'll do my best to try and point you in the right direction. But you're definitely in a good place. And yeah, I'm glad to have you here. If you want to see all this content, I'd recommend for you to visit me on YouTube, subscribe to me there, because that's where I put all the majority of my content. All right, so let's get back to this one. So find the minimum distance to the next character. So for this one, let's go back to Excalidraw. The first thing we need to do is get the alphabet, right? So I think there's like an alphabet generator that someone made here that'll just create like, just have to find the site. Let's see, alpha sides, picker wheel, the word finder. There you go, something like this. I just want the alphabet. Okay, cool. So the word that we're given for this one, let's do BZA because this one's more interesting. So the way that I see it, if we're in BZA, we're gonna start at B, right? We're gonna take 1 second to write B, and then really the question's asking us like, is it faster to go from B all the way to Z, or can we just go 2 steps back from B to Z? Like in this case, the minimum distance would be going 2 steps back to Z, right? So how is it that we figure that out? Well, the forward direction's always easy, because in the forward direction, if I want to go from B to Z, then all we would need to do is we just need to take the distance between each one of those. Now, I think one of the reasons I got caught up last time is, what if this is like z and, or maybe not even that. What if it was like G and C? Let's do GCA. All right, we'll start at G, and then if we want to go to G to C or G and wrap around to C, how would we figure that out? So what's like the best way to do this? Like if I were to go from G all the way to the right and then start over again, right? Like I think there's an easy way to calculate that distance, because one distance can just be the absolute value between both, right? Because it doesn't matter, like any two areas you pick, it can be like B and X. You're either going to go forward to X or you're going to wrap around. So it'll either be like the distance between them. And let me think about this. Yeah, I think that's where I got messed up last time, because I was always considering forward motion, but here it's G to C. So we're actually going backwards. But this might just be like, sort of like a math, not like a math question, but I think the modulo might really be helpful here. Right? Because if we just go from G to C, I can just calculate that distance, and maybe that distance always represents forward motion. I know it's not, I can't really explain what I mean by forward motion, but it's either going to be like, even if it's like, okay, F to O, for example, it'll either be this distance or all the way to the right and wrap around. If it's B to Z, it can be this distance, or no, but see, then that messes it up, right? Move the pointer one character counterclockwise, or type the character the pointer and type the character, okay, counterclockwise or clockwise. Maybe I don't really need to worry about the distance so much. I can have one case for counter. So I have one case for forward motion and another case for backwards motion. So at any point, if I'm like at GCA, how can I get from, and what happens if I just took the, like if I had 0, 1, 2, 3, 4, 5, 6, 6 to 3, counterclockwise would be what? Would that just be like 6 plus, like what's the modulo for that? Or, you know what we can also do? We can also do like from position G. If I go from 6, so 0, 1, 2, 3, 4, 5, 6. My G is 6. And the Z is 25, right? So if I go to the right, I always have to go how many places? So I'm literally going to count. It's going to be a little bit of a tedious task, but just bear with me. So from here, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Right, so forward motion would always be like Z minus G, 25 minus 6. That's forward motion. And counterclockwise would just be from, let me see, we could do G. If I go left, 1, 2, 3, 4, 5, 6, right? I can go left 6, and then I wrap around. Actually, no, if I just go left, it will just be, yeah, it'll just be G minus whatever the left one is. But then also, how do we know that we need to wrap around? I guess we'll know based on the index. So if it's B to Z, we'll do, if I want to go clockwise, I'll go from B to Z, which is 25 minus 1, so that's 24 to the right, or I can go 2 to the left. And how do we get that? We have a 1. And see, this is 25. That's the thing. Like, do we do 1, and then to 25? Maybe I need the modulo here somewhere. How would we figure that out? Is it like 1 plus 25 modulo 26? But that would just be, that's 26. 1 to 0. And why would we also get the 25? It's that last piece that's like being tricky for me. And I feel like I'm so close to it. G to 6, G all the way down, wrap around to the left. Then we get to the Z. The minimum number of seconds to type out the characters in Word. It's the wrap. That's confusing me. Any suggestions from the viewers? Like how, I know it's gonna be like a modulo trick. I'd be curious to see like what you all, if anyone has like any ideas about the modulus here. And perhaps we always like, maybe we always need to do the modulo, because what does it mean for me to go forward? If I go from 6 to 25, like what's 6? Let me see something. 6 plus 25, 31 modulo 6, 31 modulo 26, 31 modulo 25. So we can do the G. See, but that's not 6 though, right? G to C. From G over there, it's 19 forward. So how can we still get that? Would it be 26? No, no, that still wouldn't work. If we end up like getting stuck on this question again, I might just move over to another one because I don't want to spend too much time on it. And actually, what would be the next one anyway? I think I lost my place here. The next one, check distance between same letters. Let me see this one real quick. That way we're not like getting stuck on one for too long, since I wanted to keep this one mainly short. This one might be new too. Check distances between same letters. You're given a 0 index string S consisting of only lowercase English letters, where each letter in S appears exactly twice. You're also given a 0 index integer array distance of length 26. Each letter in the alphabet is numbered from 0 to 25. In a well-spaced string, the number of letters between the two occurrences of the ith letter is distance I. If the ith letter does not appear in S, then distance I can be ignored. Return true if S is a well-spaced string, otherwise return false. So ABACCB, and distance is this. A appears at indices 0 and 2, so it satisfies distance 1. B appears at distances 1 and 5. Let's see, B appears, okay, so it satisfies distance 1, 3. C appears at distances 3 and 4, so it satisfies zeros. Note that distance 3 is equal to 5, but since D does not appear in S, it can be ignored. A and A appears at indices 0 and 1, so there are 0 letters between them. Because distance 0 is 1, it is not a well-spaced string. I think what we can do is like we have the distances of A, B, and C. So like if we have an array of everywhere that they show up, or, ooh, you know what we can do? This is nice. I think this can be cool. I think we can do this a little bit, like pretty nice. So let's say we have an object literal that keeps track of the places where we've previously seen each one of these letters. So in the beginning, we haven't seen A yet, so that's fine. We don't have to worry about that case. We have A at 0, and we know the distance of A is 1, but we don't even need to look at distance yet because it's the first time we've seen it. We see the B at 1, that's okay. Then we see our next A. So our next A is at 2. Is the current I value greater than the distance? If that's the case, that's fine. So we just go ahead and update the previously seen value of 2 and keep going. If at any time we get to a character, right? If it's the first time, we just add it. The second time, we need to make sure that the distance from this one to the prior one is less than or equal to the distance of that character. I hope that makes sense. But see, this one's, I don't know how, but this one just clicked for me right away. And I think that could be a good way for us to solve it. How to improve problem solving technique? I think, honestly, once you start learning about your data structures very well and you really understand the fundamentals, it's just a matter of taking your time with the questions and really understanding them. Like, don't just read the solution and think you get it. Spend time with it, really understand it, make it part of like your intuition. So that way you don't have to worry about memorizing patterns. You just know it so well that you can just apply it. It's like, think about something that you do every single day that's just, you don't even have to think about, like, I don't know, brushing your teeth, for example. You just brush your teeth, right? Like, you want to get so good at that specific pattern or that question that you don't even think about it. It's just, it just is. Like, it's just a truth because you just know it so well. I hope that kind of imparts some wisdom on you. But let's try this one. So, let's see. Okay, so let's say character positions is equal to an object literal. So for let I equal 0, I less than s dot length I plus plus, we can say if character positions of s of I is equal to undefined, so this means we haven't put it inside of our object literal yet, we can say character positions of s of I is equal to I. This is the first time. Else, now we're looking at a new one, right? So let's say we get to A, B, and now we're at the current A. So we need to check the distance of that letter. So we can say const index. You see out here they mapped everything, right? Like A goes to 0, B goes to 1. We need to be able to normalize that. So we can say const index will equal to s of I dot car code at 0 minus 97. This will give us the character code, like in the ASCII table, the decimal value. The decimal value of lowercase letter a is 97, so I subtract 97 so that a maps to 0. And we know that we're only dealing with lowercase English letters, so we don't have to deal with anything else. Then in here, we can say, let's say like car distance, or let me see, maybe not even. We can just say if, so if the distance of the current one, right? We need the distance of the current character that we're at, and we got that with index, right? So if distance of index, let's see, 0 and 2, A appears at indices 0 and 2, so it satisfies distance 1. So if distance of index minus character positions of s of I, let's see, if distance of index minus character positions of s of I, no, actually that's not what we need to do. We need to get, let's see, I think we had it. So let's go back to the drawing board. Like our first A is at 0, and then we get to B 1, and now we're at this A. We know that every distance of A needs to be 1, and 2 minus 0, so it needs to be greater than or equal to distance, the current I, right? And does that, and how do we know that it's, let me see, const index s of I dot car code at 0, and how do I know that this one is necessarily, I guess we can do if I minus character positions of s of I is greater than or equal to distance at index, or here we should say less than distance at index, then we return false. And then here we should do the same thing, where character positions s of I is equal now to the updated value. And at the end, we can return true. I think this is a way for us to solve it. Connor Ford, with your LeetCode experience so far, have you found success in tech interviews? So I'm approaching this a little bit differently. Like I've been a full-time software engineer for 5 years. I'm not actively looking for work. I'm doing this mostly as a fun challenge for myself. And so I realize that a lot of people here are looking for, getting into that next position, looking to improve their problem solving skills. I think LeetCode is very good for that. I think that you listening to me and watching a lot of people doing this sort of stuff will definitely improve your problem solving skills. To be honest, earlier in the year, I was interviewing at places and I did get offers. However, it was I was mostly testing the market. I needed to weigh my options heavily against what I have today. And after getting some offers, I decided to not move forward with them because ultimately I'm pretty happy where I am today. But yes, I will say that doing LeetCode has made me overall a better software engineer. There are transferable skills that you can take from LeetCode and apply them to real world software engineering. But I do think, like with anything else, anything that's worthwhile, it's all about persistence. If you stay consistent with it, you will get better and you'll see results. But I wouldn't worry so much about grinding or trying to necessarily like game the system. If you just take your time with LeetCode and get better at it, then the results will come. I hope that answers your question, Connor. I know maybe it was a little more than you were looking for, but I hope it answers your question. So let me go over this again, right? So if character positions of s of I, so let's say a, if it's equal undefined, then we're gonna add a at key 0, at value 0. Then we get to b, we add 1. Now we get to the second a. We get the index of s of I dot car code. So the reason I'm getting this index is because I need to index into my distance array, right? So now if we say if 2, right, because we know that indices 2 and 0, so if 2 minus character positions of s of I, which is a, which is 0, so that's 2. If 2 is less than the distance than it should be, it needs to be at least 1 away, right? So ideally everything should be greater than or equal to the distance. If it's less than, then we know that's false. So here a appears at indices 0 and 1. So there are 0 letters between them. 1 minus 0 is, let me see, distance at 0 is 1. S is not a well-spaced string. Let's see, a appears at indices 0 and 1. So there are 0 letters between them. So I guess if it's less than or equal to the distance. Let me see, appears at indices 1 and 5, appears at indices 3 and 4. That's at least 1. Note that distance 3 is 5, but since D does not appear in S, it can be ignored. So I think maybe this change less than or equal to will help us here. So let's go ahead and proceed in this way, and let's see what happens. So here we have true and true. Let's see what this second edge case gives us. True, false, true, false. Okay, let's submit it. Okay. Wow, this looks like a doozy here. Okay, so this one's just saying that A, because the first A is at 0, and the second A is way over here. So let's see what's happening here, because this is like an easy one to test for. It's saying that the A's need to be at least, let's see, so let me just copy this string over to the console. Let's get the length of this. This is 52. Right, so the last A is at index 51, right? So that should be fine. Expected false, output true. Is there not another, I don't see another A in here. But you know what, maybe, oh, and B, it needs to be an index array, right? Yeah, that's why. So we only need to worry about else if it says that distance appears at indices 0. Because distance of 0 is 1. Note that distance 3 is 5, but since D does not appear in S, so it says if the ith letter does not appear in S, then distance I can be ignored. So let's see what's happening here, because probably for that input, what am I doing? I'm setting B to be 0, and then we get to this next one. And this is 1 minus 0. Less than or equal to distance of index, return false. That should be fine because these are all next to each other. T, U, V, W, X, Y, Z, and then we have that A. And this is saying it needs 0s and 2. B appears at indices 1 and 5. And then D, but it doesn't appear in there, so it's just ignored. 97% for the last one. Nice, man. That's awesome. Thank you for sharing, John. So what's happening here? I have a feeling that it's... So we get to the A. If I'm going over this whole string here, I get to the first A, and I know this is at position 0. Then I get to a B, that's at 1. Then I get to another B, and that's 2. So 2 minus 1 is 1. 1 is not less than or equal to the distance here, so that's okay. If 2 minus character positions of S of I, which is 1 is less than the distance of index, it's not, so we just return false, which we don't do in this case. And then we set character positions of B is now equal to 2. Then we get to C. Let's see, so if 3 minus character positions of S of I, oh, but we haven't seen C yet, so okay, we get to the next C. If 4 minus, all right. So what's happening in this one? Mod 97 for the last one. Oh, mod 97 for here? Sorry, are you talking about this question right here? Mod 97 for the last one? Trying to figure out what you mean by that. Mod 97 for the last one. Oh, yes. Oh, I see. Module 97. Okay, min time to type. Okay, nice. Yeah, we can revisit that one. I'll probably end up revisiting it in another weekly roundup because it's getting now longer than I intended it for it to be. If the ith letter does not appear in S, then distance I can be ignored. Check distances between same letters. Or where each letter in S appears exactly twice. Oh, so it only... Let's see, if character positions is undefined, then that means it would only be... So then for any other one that's not B, because I might get to... Let's see, A, B, A. When I get to C, I'll go there. When I get to C, I'll go on the next one. When I get to B, if I haven't seen it, that's fine. But what if I have like an A, B, B, C or something? Or would that work? Or A, B, C, A? I'm just thinking out loud here. So A, B, C will go on that one. And then we see this one. If I minus character positions of S of I, we only come in here if we've seen... Okay, so that's fine. The last one, they only appear exactly twice. So it's just the distance between every pair of characters. I mean, I guess we can just... Yeah, that should be fine. Const index. If I minus character positions of S of I is less than or equal to index, then we return false. It just wants it to be within that distance. Is distance I. Oh, is distance I. So it needs to be equal exactly. But so it's set, no. No, because distance of 0 is 1. And this is 2 and 1. So it satisfies distance 0. Is it just because there's one, oh, there's one letter in between them? Here, 5 and 1, 0, 1, 2, 3, 4. Oh, I think we can do 5 minus 1. Yeah, I think we can do... Okay, I see. I think this might actually need to be I minus... Okay, if I minus character positions minus 1 is not equal to distance... Because we did something like this recently where I was trying to figure out like the amount of items between two indices. I think we just need to also subtract 1. B, okay. run this again. If I minus character positions, of course, we don't want the else if. What's happening here? What happened here? If character, oh. See what we got. So we got true and false. Okay, let's go ahead and put this one here. And my input, okay, so let's just copy this whole thing, put it in our test cases. Let's run this. True, false, false, true, false, false. Let's run. Okay, cool. 56.79. Yeah, this like little formula right here, just to figure out how many items are in between two indices. It's just this, but we need to also subtract 1. 56.79. I like this one. I think this is really good. There's like a very common pattern of just using some data structure to keep track of previous indices, and then finally we just compare it once we've already seen it. I think we can probably do even better, because here what we can do, yeah, let's try this. What I'll do is I'm actually going to set this now to an array, and since I know everything is going to be lowercase, I'm going to fill this up with -1. This is going to help me figure out if I haven't seen it yet. So if character positions of, let's see, not s of I, now we need to get the index, right? So here I can move index out here. I can remove this from here. I can say if character positions at index is equal to -1, that means I haven't seen it. So then I can say character positions at index now is equal to I. Else the second time I come around, I'll do if I minus, let's see, character positions of, yeah, I think this will also be, we can make this index here, character positions of index -1 not equal to distance of index, return false. Else character positions of index is equal to I. Let's see, true, false, false, true, false, false for all our different test cases, right? Because we still have the old one. So let me run this one. Okay, yeah, it should increase now, right? Because we're doing better with our space complexity here. Like now we're not using an object literal anymore. If you think about an object literal, like there's no way for your program to know ahead of time how much will potentially be stored in that object. Whereas when we use an array, we're being very explicit in saying that we're only ever going to use this many slots. And because that's a contiguous block of memory, then it's easily optimizable by the engine. So it's just another nice improvement we can make here. And I think if I sort of reverse it, because this is happening in both of these, right? So I think we can always, let me see. I can probably always, if character positions index equals 1, I want to set it to I, but I also want to, like, I kind of want to do it every single time, but I only want to do this. Yeah, let's see. Okay, I think I know what we can do. I can say if character positions at index is not equal to -1, I can do this, but we should always do this piece here, right? Character positions index of I. And we can probably even make all this like a longer if. So let's try that. Let me just run the code for this again. I'm trying to make like incremental improvements here. True, false, false. Okay, we'll submit that to make sure everything's good. Okay. And now in here, what I can do is we can just copy this. I'll remove all this. I'm going to set this on 2 lines to make it a little bit easier to read. Okay, let's remove these. Let's remove this. Okay, and we said return false, right? So I think I'm missing a parentheses here. Yep. Probably we really don't even need this. So if character positions at index is not equal to -1 and I minus character positions of index -1 not equal to distance of index, return false. And like, if I just expand this all the way, I really could just have it on the same line or something like this. Let's run this. Sweet. All right, 81.29. So now we're looking at like one of the best time complex solutions that we've gotten to. So I like, yeah, this is also a very nice question. We were able to essentially reduce the complexity down to constant space complexity, and our time is just going to be n, where n is the length of s.length. So yeah, I think that's really great. I'm pretty happy with like the weekly roundup today. I think we ended up doing, we started off at what, 269, right? So I think we just did one more. So we did 2 questions today. Yeah, I think that's solid. That's like a solid weekly roundup. So thank you all to everyone that joined. If you're watching me on Twitch, highly recommend that you follow me on YouTube, because that's where I put the majority of my content. I have a lot of things, you know, like these weekly roundups that we do. I have some videos related to LeetCode Explore cards. I have some front-end project stuff I've been doing. One of the things that I'm actually very excited about, one of the more recent things I've done, is a podcast that I'm starting called Castware. You can find that channel that I started. It's just the Castware channel. And you can watch the first podcast episode I did with the moderator, one of the moderators on my Discord channel. So if you're interested in any of that stuff, make sure to follow me on YouTube, subscribe to me, ring that notification bell. Really helps me and you know, helps the algorithm put this content out to you all. So very happy with everything. And yeah, we'll see you all again tomorrow, where we'll go back to our normal LeetCode streams, where we're just doing questions and just trying to do as many as we can. All right, so with that, hope you all have a great rest of your Sunday, and happy coding.